Every map you have ever seen, every road alignment, every plot boundary, every dam and metro line, they all begin with the same first step. Surveying, and before you touch a chain, a compass, or a total station, you must understand two simple principles and one classification tree. Master this one foundational lesson, and you have locked in one or two guaranteed marks in GATE, ESE, PSU, and SSC-JE, plus a rock solid base for everything that follows. Let's begin. So, what is surveying? Surveying is the art and science of determining the relative positions of points on, above, or below the Earth's surface by measuring three things: distances, directions, and elevations. Notice the word relative. We always locate points with respect to other points and don't confuse it with its cousins. Leveling deals only with heights, and setting out works the opposite way. Instead of measuring the ground onto paper, you mark a design from paper onto the ground. Now, the two fundamental principles. The first and the most asked single fact in this entire topic is work from the whole to the part. What does that mean? You first fix a framework of control points covering the whole area with high precision. Think of large triangles laid across the region. Only then do you fill in the smaller interior details with lesser precision. Why this order? One reason, and remember it word for word, to prevent the accumulation of errors. If instead you worked from part to whole, every small error would add up and magnify across the survey. So big framework first, details later, and errors stay trapped in their little zones. The second principle, the position of a new point is fixed by measurement from at least two points of reference whose positions are already known. Why two? Because one measurement alone, say a single distance, only tells you the point lies somewhere on a circle. You need a second measurement to pin it down. Given two known stations P and Q, there are five standard ways to locate a new point R. Measure two distances, or a perpendicular offset plus a distance, or two angles, or one angle and one distance, or a distance along the line and an angle. Every surveying method you will ever learn is just one of these five in disguise. Now to classification. The primary division of surveying rests on a single question: do we account for the curvature of the Earth or not? If we treat the Earth's surface as a flat plane and ignore curvature, that is plane surveying. It is used for small areas, lines are straight, a triangle's angles add to exactly 180 degrees, and accuracy is modest. If we do take curvature into account, that is geodetic or trigonometrical surveying. It is used for very large areas, lines become arcs, triangles are spherical so their angles exceed 180 degrees, and the precision is the highest of all. In India, geodetic surveys are carried out by the Survey of India. Here is the part examiners love: the numbers that justify plane surveying. Take a line 18.5 kilometers long on the Earth's surface. The curved arc is longer than the straight chord by only 10 centimeters. That is 1 part in 185,000, negligible. Now take a triangle enclosing an area of about 195 square kilometers. The spherical excess, that is how much its angles exceed 180 degrees, is just 1 single second of arc. That is why, for any area up to roughly 250 square kilometers, we happily treat the Earth as flat. Below that, plane surveying; far beyond it, geodetic. Beyond plane and geodetic surveying is classified 4 more ways, and here's a memory hook to never forget them. IMNOI for instrument, chain, compass, plane table, theodolite, tacheometer, total station; M for method, triangulation and traversing; N for nature of the field, land surveys like topographical, cadastral and city; marine or hydrographic for water bodies; and astronomical using the stars; and O for object engineering, geological, mine, archaeological and military surveys. So when a question says cadastral survey, that's nature of field; triangulation, that's method; theodolite survey, that's instrument. The basis is the key. Let's lock it in. Two principles: whole to part to prevent accumulation of errors, and fix a point from two references, minimum two measurements. Primary classification by curvature, plane versus geodetic, with geodetic done by the Survey of India. Secondary by IMNO and the magic numbers. arc minus chord 10 centimeters over 18.5 kilometers, spherical excess 1 second for 195 square kilometers, and the plane limit 250 square kilometers. Get these and the whole topic is yours. If this made the basics click, hit subscribe to learn civil easy. We publish a fresh concept every day for GATE, ESE, PSU, and University. The practice MCQ paper for this topic is linked below, with a full solution video to follow. Download the free notes from our Telegram. Keep it simple, keep it consistent, and I'll see you in the next one. Happy learning.